Dzień dobry.
Witam Państwa. Chyba działa. So welcome. This is the third time we meet on information systems modeling on the lecture that will assisted with the laboratories. And during the last laboratories, I asked you to play with REST services. I ask you to prepare API which could be used to query for data and retrieve information from somewhere, from the service that implements this REST API. So let me come back to that subject, and I will explain more details on that subject, and I will also show you some other subjects during today's lecture. I want to show you some examples of common design patterns and some other, I hope, interesting features of Java. So let me close the camera and I will show you my screen. Can you see it?
Yes.
Okay. So I don't know whether all students got the link to our lecture. I can see only 18 students connected, but anyway, I will start this description. So let's start from this slide, from the slide with the URI. Recently, I told you that when you are implementing REST APIs, you should put, or you should consider under which endpoints you are going to deploy your service. And these endpoints are offered under URI. And inside that URI, you can encode some parameters, some attributes. So in general, URI, this is a uniform resource identifier, and this identifier has been standardized. There are some particular RFC documents which have the description of what is the content of this URI, what are its parts, and how they can be combined together. So in general, the URI follows that pattern. At the beginning, there is a schema, then hierarchical part, then a question mark, and query, and fragment. And what is nice is that URL, which is a kind of URI, has such a structure which is very known to you. There is a HTTP as a schema. There is an example org or any other domain name of the service, and which is followed by the path. And after the question mark, if the attributes are handled, you can put these attributes. Sometimes at the very end, in the URL, people put hash and some other text. In fact, according to the specification of HTTP protocol, this fragment is not considered as a part of the query and often is just skipped by the servers. So fragments are used to show or to point to the part of the resource we want to receive, but in general, during the communication, they are cut or they are skipped by the services. So we are not processing in the REST API these fragments. So what else? There is also IRI, Internationalized Resource Identifier, which is, how to say, like an extension to URI, but this extension allows you to put international characters inside the URI. And HTTP protocol, as I already said, is the protocol which runs above TCP/IP protocol, and this protocol is a textual protocol, and it has some version, and the most commonly used version is version 1.1, which has several methods. Each of these methods has a special meaning, or it is used to do some very specific operations. Get is for information retrieval without any attachments, right? So everything is encoded in an URL. Post is for getting the responses from the service, but you can also attach to your request some attributes. So in general, post is used to create some new resources on a service. It is used to send a new data to the service. Put is very similar to the post, but put is used mainly to update content on the service. So if you look at the pet shop store example, which was displayed when you first time opened Swagger editor, you could see that that put method was just for those methods that updates data. So let me open again this pet shop. Okay, I will come back to this view in a minute. So if we go to the Swagger editor and we have at the very beginning pet store, you can see that put methods are used to update data. This is the meaning of this pet of the put method. So if you are talking about REST API, about REST methods, so the behind that are and the RESTful, in fact, methods. So we are talking about using HTTP protocol methods, but for specific purpose. Posts are for uploading new data to the service. Put is for updating data for inside the service. Get is for data retrieval. Delete is for data removal. So if you want to remove some resources on the service, according to the this RESTful approach, you should use the delete method to do it. Of course, you could also delete some parts of the attributes using get method. There is nothing wrong, right? It is possible to use get method also for data removal, but it is not correct according to the idea of these RESTful services, and this is not correct according to the some security rules. It is interesting that this post, put, get, and so on method of HTTP protocol can be handled by the configuration of the web service. Web service, for example, Apache or Tomcat, can be configured in such a way that a request sent with using of the get method will be processed without any restrictions. So other kinds of the request can be configured in such a way just to check whether the user has a permissions. So this kind of configuration is done usually on a web service, right? On the web server, sorry, on the web server. On the web server, you can modify its configuration just to open and get and open endpoints which are queried with the get method for anyone, and close some endpoints which are queried with the use of other methods just for the registered users. So this is also important, that behind this pattern that you are using post to add a new, delete to remove, get, and so on, you have also some kind of the design pattern, right? That the get can usually, these are public methods. Usually gets are not hidden behind any logins. However, under certain limitations, and I will talk about this limitation soon. So in general, if you are sending requests, so you are sending that kind of the text to the particular endpoint, to the particular host under the specific path, and this path is just after the get request written here. And next there are headers and its values. And after receiving that such kind of the request, server prepare the response, and the response has also request header, has a headers and a response line. So this is how it looks like when you are sending and getting back responses. In general, this part which are general appears in the requests and the responses, and the parts of this protocol, the parts of this headers which are request specific and entity specific, like might appear in this textual message in various places. Sometimes these headers which are common for both requests and responses, or which are very specific, are mixed inside that. It depends on the implementation, who prepared such kind of the request, but in general, the server should be not aware about the order of these attributes. The most important thing is that all the required headers are existing in that request. So these are some other examples how this request can be composed. And another one, and as you may see, if you are receiving some response from the service, this response is attached to your to the response you are receiving, and somewhere inside you have the description of what has been sent back to the client. Here is the content length and content time. So the service informs the client how big is this response, and how what is its type. So everything is in these headers. I already mentioned during the labs about the HTTP status codes. So in general, they are divided into 5 groups, and in these groups you have more specific explanation what are the meanings of the particular status codes, and you can refer to the resource I mentioned here on this slide. There is a good description, and as I said, playing with the RESTful APIs, you should use URI in order to encode your requests and encode responses. And this requests in responses also must, how to say, be configured in that way that some specific features of the HTTP protocol must be taken into account. So what are these features? And in general, the HTTP protocol is stateless. What it means? It means that when you send the request and afterwards you send the second request, the server does not necessarily will adjust its state according to the first your request. So if you are, for example, moving from one page to the other page, so server, when it's use pure HTTP protocol, that will not, how to say, assume that you already moved from the first page to the second one. So the server, this state must be somehow simulated, and it is done through cookies. The cookies are just part of the HTTP protocol. These are they are included in the headers and stored inside the browsers. And thanks to these cookies, so these states are emulated. However, this HTTP protocol is not stateful. Is a protocol which is a stateless protocol. So going further, I already talked about the Swagger and the Swagger editor, and we already played with the Swagger code again. So on that slide, you can see you have some hints that if you would like to download to your computer the source code of that application you are running on the web, you can download its source code, cloning the resources from repository, and then you can just run the code again client, which is the application which generates the resources, generates the template of your services or your clients, depending on what you are setting. What will you set in the list of the attributes passed to your application? If you are going to and generate a Spring Boot ready code, so with an option -l, you specify the Spring as a target environment, which should be for which the source code of your template of clients or services must be generated. So I already showed that how it works, and I prepared for you another example, and let me switch now to this example. So I must go to my folders. So just a second. Where I have it. Oh, I know. So, and so let me check. So I'm already running two clients, not two environments, pure Eclipse and Spring Tool Suite. I want you to show one of the YAM files I generated, but I need to wait a bit until the environment will start. So 1 minute, please. Okay, so let's switch it off. It's now open. Okay. Here is the example of a very simple REST API. I have two methods, get and nothing else, right? One get and the second get. But the first one is the method that requires to put an attribute in the URL, and this attribute will be used for something. In that simple design, I said that if I want to retrieve items by name, so if I want to filter them out, I can send the request under item URL under item endpoint, and I can put that particular name as an attribute in it. And that's it. The responses will be provided as here. But I have also another get method, and inside that get I declared some additional attributes. When you look on the description inside YAML, you will see that here I have parameters, and the parameters are declared as a being in a query. It means that I wish to send two attributes, offset and limit, which will be used when I start to implement this service, just to make a portions of the responses. I want to have to deliver to the client the responses in groups. Limit is the number of maximal entities that will be returned, and offset is how to say, the beginning, counting from the very beginning up to the place declared by the offset, and from that place the next number of items will be retrieved from the service. So here you have the declaration in YAML, how to declare such a limit and offset inside your description of get method. And thanks to that, once you start to play with it, for example, I want to start with from the first, and I want to retrieve 10 elements. So the request which will be sent to the endpoint will be the request that has encoded these two attributes inside the query part. So here is offset equals 8, 1, and limit equal 10. I have declared the endpoint that accepts also attributes given in a request line. So this is what I want you also to consider when you develop your own API during the lab. Please remember that whenever you have the request that can deliver a lot of data to the user, you should partition them into the portions. Do not offer all that you have inside your service, because that might be a quite large volume of data. Just give a chance to the client to declare which portion, which parts of your of the data he or she is interested in. In general, when you implement views for the web service, so in most cases, this under the views you have the outputs presented on the pages through which you can move from one to the other. So this is done just using offset and limit. The pagination, this is a term which is used by the web programmers, just rely on using offsets and limits. All right, so this was the remark to the REST API, but the main topic of this lecture is our design patterns, and I wish to switch to them now. Recently, I gave you some remarks about DAO pattern, the pattern that is used when you are trying to implement interface by which you access the data stored somewhere in a memory or in a database. So DAO pattern has been discussed last time. Now let's look at the other design patterns. If you wish to study these patterns, there are a very nice book, and I told you that there is a design patterns, elements, and of reusable object-oriented software. This is quite old book already from 1994, but this book was a fundamental book for object-oriented programming, and the authors were called as a gang of four. There were 4 authors, and they created that book. They wrote that book, and it's very well known now. So in general, design pattern is a structure that is used to solve some problems. And these problems are very common in programming. And once you have the one solution, you can apply that solution to many implementations. So this is the reason why these design patterns are so important. So they are reusable. They can be adapted to many problems, and usually, they use some object-oriented concepts like aggregation, inheritance, encapsulation, interface, and polymorphism. So you will see in a minute how they work. In general, patterns, if you want to share your pattern with someone, if you design some very specific data structure or very specific behaviors inside your source code, so the description of that pattern, once it is deployed somewhere, should consist of name, the description of the problem, the description of solution, and the consequences of the use. Sometimes also there are descriptions of how that shows the dynamic behavior of that pattern, of applying of that pattern. So this dynamical behavior is represented with sequence diagrams written in UML language. So in regarding this gang of four patterns, they have been categorized into three groups: creational patterns, structural patterns, and behavioral patterns. Creational patterns are just used for creating objects. So these are a good way of making data or preparing data of particular type. And structural patterns is good. These patterns were designed for bigger problems when you have the dependencies between various data types and you want to group them somehow and access somehow. So dealing with these problems is easier when you are using structural patterns. And behavioral patterns are patterns which are in general designed to handle some actions, to handle some events, to handle some execution flows which are common to some problems, and should be how to say, it's good if they are handled with the use of well-designed software, the software that follows some patterns. So The patterns have names. So there is a factory method, abstract factory method, builder, prototype, singleton, and so on. If you want to put them into the categories, into creation of structural and behavior, they just fall as it is shown in the table. And inside the table, you have also additional categorization. Some of these patterns are, let's say, class and subclasses related, and they are statically defined at the runtime. And some of them are just object-oriented, and they declare object relationships, and these objects are manipulated during the runtime. So there are some other categories, and I will leave this not commented because I want to switch to the examples. So in general, design pattern should have the name, intent, sometimes it has some descriptions, whether it is known under different name, motivation. These are just keywords that declare the scope of the description which should be attached to the design pattern in order to make them usable to the other users. So let's see the singleton. Hey, did you hear about singleton before? Is it known to you? Yes or no?
No.
Singleton is, as the name depicts, the proposal in which we handle or we create a single object, single instance of particular class, which is shared by all other classes inside the program, inside the application, or inside the system. In general, when you work with a singleton, you want to have a global, let's say, variable. If you want to have something that is shared by different parts of your implementation, is kept in a memory during the long lifetime of your application, so the singleton is that solution you probably want to use. And there are several implementation of this design pattern, and sometimes students just use it without even naming them as a singleton, and sometimes the singleton is not used correctly. So let me explain what I mean by the correct use, describing this during when I enter details of this pattern. So let's see. Here I have the UML diagram, which at the first view does not give us too many information. I knew that I have a demo. This is the application which will use the two types, client and a singleton. So inside the domain, probably there will be an instance of a client created, and there will be also a singleton class used somewhere. So I can see that client has its own constructor, and that client has a singleton initializer method. Okay, so this singleton initializer method will create the instance of the singleton, and singleton is just the class I want to have, which one instance of that class I want to have in my implementation. So how it will work? So the demo just will create the client object. Inside the demo source code, I will call singleton initializer, which just will create a singleton through the call of the get instance method. Get instance just will create a singleton instance, and I have now two options. So if the instance was null, then the singleton will be created. So the constructor of the singleton will create an instance of the singleton, and this singleton instance will be living from that time during the execution of the program. Since that moment, this singleton will be available. So the client, after creating the singleton, can call operation on that singleton. Singleton delivers operation method, and once created, any part of your implementation, any class which lives in demo can call get instance on to retrieve the singleton, and this singleton will always return back the same instance under which you can call the operation method. So this is how to read this sequence diagram. So after having the sequence diagram, I knew the algorithm by which this pattern can be used, can be implemented. So how it looks inside the source code. So singleton is as I said, the class that delivers me something that will be shared by different parts of my application. So singleton class has a private static member, which is of singleton class. So here is the instance. At the beginning, that instance does not exist. That instance will start to live when someone will call static method of that class, which is called getInstance. And here is the implementation of it. So if the instance was not initialized yet, then the method new singleton, so the call for the constructor of that instance will be issued, and the instance will be created. If the instance has been already created, so the reference to that instance will be returned from that getInstance method. Here is the private constructor. Can you see this private access modifier? So constructors can be declared as a private. So if it is done, since that you cannot run constructor of the singleton outside of that class. So you cannot create object of the singleton using the constructor if you are somewhere in the other class. So this is very important. So the constructor has been made private. The only way of getting an instance of the singleton is through getInstance method. So this is, as you may see, quite interesting. And the other interesting part is here. Look, at the beginning, my singleton, when I call getInstance method, my program will check, or my execution flow checks whether this instance exists or not. So if you are working in multi-threading environment, so every thread can check it, and if there is something that is different than null, so every thread can safely receive that instance. So the control flow will not fall into the body of the if condition, but the control flow just will go to the return, and that instance will be returned to these threads. However, if the instance were not existing, look what is inside. There is a synchronize keyword, and synchronize is done on the singleton class. It means that if you run that getInstance method from different threads, so the creation of the singleton will also be done only once. There will be no chance that two threads at once start to create a new singleton. So this is a synchronized keyword, which is the keyword. This keyword is a part of Java language, and this keyword was used here just to protect access to the static part of the class, and especially to the creation of the instance entity. So this is how it is done. So I want you to see that having a singletons in your code, and if you are thinking about multi-threading applications, can be tricky. And this solution is quite nice. This is a singleton which is protected when you use it in a multi-threaded environment. Okay, so here is the this part, and here is the client, and the client has a singleton initializer, the method which just call get instance. So I would say that if you create this instance of the client somewhere, and if you call this get singleton initializer, and in the other thread you will call also a singleton initializer. So in fact, you get exactly the same instance here as the output of the get instance method. So once we have the singleton initializer, we can call on that singleton an operation we just want to run in our application. So how it is really used. So here is a new client, and we call initializer, and here is a direct call to this singleton. Here is a singleton, and I call the operation on that singleton, and here is again call to get instance of the singleton class method. Here I have another singleton, and I call the operation on it, and in fact both singletons are just exactly the same object. So this is the way by which you can declare such a singletons. But having how to say declaring classes like here, and declare the operation and the fields like here, which is private static, might be also tricky, might also follow some design patterns. I prepared for you the example here. So I have here some classes that offer some methods, and they have some fields. So in common, many Java frameworks use plain old Java objects, so-called POJO objects. This is well known. POJO are well known in Java community. These objects are declared using existing Java classes without any, how to say, other classes that comes from outside of the Java API. So all which is used when you declare Java, this item POJO are classes which are in JDK, Java JDK. You are not using here when declaring the fields of that class any other data types. So here is the constructor, and this constructor is used to initialize the fields of that POJO object. Here is the method inside this POJO, which is called name. And as you may see, this name is a method that takes the values of the fields and concatenate them and return. I access this fields using this keyword, which means I refer to the instance of my class, but I can also access this without using these keywords, because once when I am implementing the body of my class, I am referring to the fields of that class. So in fact, I am working on an instance of that class. Okay, and now I have a get and set methods. This is also common that if you have the private members and you want to give a chance to modify or read the content of these fields, so you should deliver get and set methods. So they follow also a naming convention. So at first there is a get keyword and set keywords, and afterwards there is a name which usually matches the name of the attribute, but it is written in starting with the uppercase, and such a notion is called camel notation. Camel, because you have like a like camel, you have lower and upper cases somewhere. So okay, this is a standard POJO object, but this is not the only thing. Sometimes in various in various frameworks, the classes that are used, the data types that are created by the programmer are Java beans. So in general, Java bean is the concept which was, how to say, declared or designed in Java just to make some frameworks or to submit some features which were not existing in Java. So in general, let me explain. So in general, there is also so-called naming convention. If you are working with Java beans, so this is, let me emphasize, Java beans, right? So this is the term I am using. If you are implementing Java beans, the class you're writing should have a bean inside its name. So this is the naming convention. Class can be called with any words, the name of it, or there might be a mixture of many more words. However, at the end of the name should be a bean. Moreover, according to the specification, or according to the to the bean convention, every bean should have a constructor, the public constructor that takes no arguments. And every bean should be also serializable. It means that it should be possible to serialize that the bytecode of the instance of that class to the stream. So because beans can be sent and retrieved through the streams. What else? Every bean has also get and set methods. However, these get and set methods, now they have also a very special meaning. So in Java, there is no way of declaring so-called properties. In other languages, like in Microsoft Visual Studio, C# or C++, or in C# or Visual Basic, you have the concept of the properties. Language has some constructions, some constructs that are used to declare how to interpret assignments. So if you have the reference and you have the some kind of the objects, so depending on whether you are on the left or on the right hand side, so the having these properties, the data are, how to say, retrieved using get or set, which are embedded inside the language. So can I find it in a very short way? Let me see. So if you look for the properties in C#, so in the C# you have the some kind of the constructions. You have get and set. Is it correct? This is normal. Okay. Or let me see properties. Okay. If you are using Visual Basic, so there is a specific construct in the language which is called property, and the property is named, and the property has a get and set parts, and here is a get method and a set method. So in general, there is a construct of the language, the grammar in the language that is used to declare properties. In Java, there is not such a grammar. In Java, to receive the same result, you are using get and set methods. So we say that a particular class has a property which is called model if I have get model method. Inside that get model method, I can have several other how to say commands. I can put here complicated algorithms. I can access several private and public fields in my bean. In general, what is seen outside of that class is only information that I have the model property, and this model property can be retrieved using get and can be set up using set method. And that's all, right? So can you see, in general, if you are working with the beans, so you have the naming convention for the class, you have the public constructor, your class should be serializable, and you should use get and set method in order to access properties of that bean, and usually this properties matches, but necessarily matches the private fields of your class. So this is the second example. So now let's go to the DTO. So if you wish to transfer data between endpoints and your business logic, so usually this is done with the use of DTO classes. So DTO classes are, how to say, quite similar to the bean classes, right? However, there is no necessity to make this DTO object as a serializable, and there is no naming convention here. This DTO that I inserted is just to let you know that we are playing with the class that can be used to data as a data transfer object. However, there is no obligation to put here DTO. And what else? Inside item DTO, there are not behaviors. Can you see? There are only get and set methods. Inside that class, there are no method that deliver business logic. So DTO objects are just to preserve data, right? Just to represent a data, just to hold like a structure in C++, right? or structure in C. They collect data and they are used to move data between different parts of your application. But in general, if we are talking about the model in which you are using the values which are used just to place the values and move and transfer the values. So maybe it would be good to apply the value object. In that design pattern, the instances of that classes should be unmutable. What it means? It means that once you create the object, you cannot change the object fields. So this is the idea which is hidden behind item VO. So every field inside that class is a private final. So once a value will be assigned to the particular field of the instance, it cannot be changed anymore. Therefore, in that class, can you see, I have no set methods. There are only get methods to retrieve these private fields. Moreover, here I have the implementation of equals and hash code. So usually, if you are working with value objects and you want to check whether two value objects are exactly the same, this can be done using equals and hash code methods. And here is the example of the implementation. In fact, if two objects will get the same attributes and if they will be compared then using equals, so the equals method will return true, and the hash code should be also the same because we are comparing the value objects, something that delivers us the value. Okay, but this is not all, right? I have another kind of the design pattern. This design pattern has been introduced in Java language in JDK, I think 15. It was in that version, the feature that was just a preview. Normally it was not used, it was declared as a preview just for testing. But since Java 17, this record is a part of the language. So we can now use in JDK, in writing Java program, starting from JDK 17, a record keyword. What this record keyword means? This is not a class, it is not an interface, it is a record. The records are treated in a very specific way. The compiler, when compiles such records, just convert them to the very specific class. So let me show that class. So here is the example. If I would implement a final class, so the class that cannot have any child classes, which has a field which are unmutable. So once initiated, they cannot be changed. If I have the access methods X, which are named exactly as these fields, and if I have equals, hash code, and toString methods implemented, so such class is exactly the same what I will receive declaring a record with a particular and X and Y attributes in its constructor. Java just will compile that record into the class that has, which is a final class, which has a constructor and it has public fields and toString, hash code, and equals method available. So do you understand? This record is nothing else but the syntactic sugar. It is the construct that was attached to the language, but this construct does not, how to say, change the behavior of the virtual machine. The bytecode which will be generated will be the byte almost the same like the bytecode which is generated for the common Java classes. However, here I have the, as you may see, extended Java lang record. So in the API of Java JDK 17, in package lang, I have additional class which is called record. So this is which is not existing in other JDKs, and therefore even the class looks very common. It looks like any other compiled class of Java language. However, because of this extents, I can use that class only in Java JDK 17. All right, so this is the meaning of the record. So it's quite simple. If you want to pass the data like a value object, like that one, so it would be easier to declare it as a record. This is what is in JDK 17. And one of the last thing, I think, but probably it is not last really. There are plenty of frameworks that can be used to design your classes in particular way. So this is the Lombok. Lombok is a framework which runs, or which should run during the compilation of the classes. And that framework defines some annotations. And with use of that annotations, the classes you are writing might be shortened. So here I declare the class item Lombok, which has some private fields, right? And no other methods, nothing else. But see, here are getters and setters annotations, getter and setter annotation attached to that class. Lombok, it's a framework that will compile that class. The bytecode of that compiled class will include get and set method for these fields. So this is something like a record, right? I have the class which is declared with the constructor. Inside that constructor, I named the attributes of my class, but in Lombok, I declare the class and its fields, and annotating them with getter or setters, I will have the class which has already this get and set methods already in it. The compile class will have them. So how to play with this? Look, I am in the main class, and here I am creating a new item B. It's possible. I am creating a Lombok. New item Lombok, it is created. And I here access this set method. Let me show again. Item Lombok, I have no access method inside the class. However, I have a getters and setters. And inside my main class, which is the place I am using this Lombok, I can call set methods whenever I wish. Set, for example, rate, right? These methods are accessible, and as well get and set methods. So item record here is the example how to create the record, and I can access the fields of this record using model and version access method. So not gets, but the methods which are named exactly as a properties. IR, as you may see, there is a rate and other methods that are not getters and setters. So this is the difference, in fact, between what I get from Lombok and what I get from using record. If you want to play with these kinds of the thing. So please read Lombok descriptions, Lombok framework description, how to install the Lombok inside your programming environment and how to run the application which are using this Lombok. In general, this is not very complicated. I am just added some dependencies inside my POM file of my Maven project, and I run the installation, which put some. I can show you the installer of Lombok in general does a very simple thing. Not that part. I go to the development and Eclipse. It puts Lombok ER inside the main directory of my Eclipse, and it also puts some additional entries inside Eclipse ini file. So at the very end, you will see that this is a Java agent, and here is the link to Lombok jar. So having that Java agent, when I start my Java applications, so the agent does additional work. So this is how to say advanced Java programming, and usually the programmers, when they are using some frameworks, they just take these attributes and forget what is the meaning of these attributes. But I want you to remember that this is how to say advanced programming, and virtual machines, before it does some operation, it runs an agent, and the agent is declared inside the jar. All right, so I also prepared for you some examples how to query the REST API services. So on the web, you can find the very nice portal, which is called GeoDB Rapid API. Let me check it. Okay, here is Rapid API portal, and under that Rapid API portal, this is a cover under which you can run some different APIs. So in general, there are several free APIs which can be used just for testing. If you are implementing some some applications and you want to play with these applications, you can access this application using Rapid API. Rapid API allows you to create, how to say, to use. Oh, let me show free API, REST API. If you look for them, Rapid API just documents the collection of free APIs. So there are 37 already registered. One that I would like you to concentrate is GeoDB. And GeoDB, if you go there, you will find out that this is the application that can be accessed, and you can run the queries against that application. In fact, you can subscribe for particular endpoints. In order to test particular endpoint, when you enter that page, first you must register using your credentials, GitHub or Google credentials, and once you register, you get you can apply for AP key. This AP key I am showing you, this is my private AP key, but this AP key is for 100 requests. And when the limits will be overcome, so it will stop to work. So I'm not worried that you will use it. This is a free key just for testing. Why I'm talking so many words about this AP key? Because in many cases, REST APIs are hidden behind a security layer. And this security layer usually is handled with the use of the keys. When you send the GET request to your endpoint, if your service has implemented some kind of the protections, some kind of a security mechanism. So then you can, if you are using security API, then in the call to the service, usually you're supposed to deliver the key inside your request. So look, here is the GET request, which goes under that endpoint, and it is also with the parameter, which is radius, and here you have the key, which is one of the HTTP header headers. So its value is here. This site is very nice, this rapid API, because you can see how these requests can be written in different languages. For example, if you want to use HTTP request, so this is the class which is available in Java API. So to send pure GET request, you can create object request. In that request, you just specify the URL. Here I have a radius attribute inserted into the request field, and I have also this rapid host and the rapid key attached to my request, to my headers, because otherwise I will receive some errors. And method I want to send is the GET method. After building, I am just sending this request, and after receiving a response, I can do something with the body of this response. So this is example how you can write requests using Java HTTP class, which is in Java .NET package. And if you want to, for example, to see how it works with OK HTTP class, I think that OK HTTP client class is a part of Apache library. So the same request can be sent in that way. If you want to see how, for example, it will be written in JavaScript, if you are using jQuery library. So here is this request. So this is quite nice site just to see how the same request can be sent using various programming languages. Okay, so if you have, let me, I already, okay. If you have the Swagger editor, I told you that you can generate a Spring server template, but it's possible also to generate client if you wish to implement a client to your service. And here you have also Java, JavaScript, and different languages. You have a C#, so you can also declare it as a Java. So when I press it, and so client is generated. If I open this client with my program, I will see that this is the Maven project, and in the sources I have a main, Java, IO, Swagger, client, and I have here some classes generated already to access that endpoint. Moreover, what is quite nice, I have here also the classes that are used to handle the data types which are here. Do you remember how I called these data types today, just a minute ago, or some minutes ago? What kind of the class it is? It is a POJO? It is a value object? What kind? Do you remember?
Oh yeah.
DTO.
Wasn't it beans?
It can be interpreted as a bean because it has a get, set methods and so on. However, if we are working in a Spring Boot framework, so to be a bean, that class would need to have additional attributes, additional annotations. It has no additional annotations because let me inform that beans which are in Spring Boot framework are a bit different than Java beans. Okay, so these are also beans, but treated in a bit different way. However, this is a DTO, the data type that is used to deliver object to the client and send the object to the service. So this is in general DTO. It has a private fields. These private fields are accessible by get set methods. Here we have also the methods which are called as exactly as the fields in this object. And what else? I have here the schema. Okay, I don't know the schema. What is this for? And this is all. And I have to string and to indent and string just to display nicely it on the screen. And that's it. But I have also the items. So as you may see, the items is the class which extend array list. What is nice here, you can see that if I declare inside my API description that some of the outputs, okay, this is maybe no, okay. Here I have get methods, and the output which is declared can be a list, right? So not only one object, but the list of the objects. So here is that get, and I say that the output which will be generated, it is declared inside the items section of the schemas. And item is here declared as an array. So sometimes you can get confused because one time I am saying the list, one time I am saying an array, one time I am saying a collection. So always everything depends on the context. So if you are declaring the API using YAML, so to declare the set of objects, the collection of objects, you are declaring type as an array. So and this is the array of items, and name of that array, if it will be encoded into XML, will be items. So this is what I put here. I don't have here the name for the JSON because when I am encoding in the JSON, so my nodes have no names. So therefore, there is no need to declare the name for that particular object in JSON encoding. Okay. So this is what I received. I received data types, and I received also the items class, and this item class, as you may see, it is generated, just generate this array as a just generate it as an array list. So this is the mapping that was used. Of course, it does not necessarily to be an array list. You could declare also this as a linked list. Sometimes people just overwrite that generated code with other kind of the collections just to make use of the particular features of these collections. But in general, what we have here, it should be, how to say, convertible. It should be recognized by the serializers. And these serializers, okay, let me come back to the zip. These serializers you will see in this generated code. Here I have a JSON Java. So I have a JSON Java which was generated by my source code, and inside here are some adapters, and these adapters are used to convert Java classes into JSON format. And okay, this is, let's say, a quite big part of the framework. So I am not. So we have no time to discuss the details how that framework works. But let me just say that that generator is able to generate for you a lot of additional classes which will convert JSON to objects and to Java objects, and vice versa, without any efforts. Everything you have here somewhere inside your generated code. You can also work by yourself, and let me show this REST API, which was on GeoRapid, okay, that endpoint, which let me check to the cities, okay. I have the cities endpoint, and I can send the request using this interface, and I see that I retrieve the data from my service, and here this data are. So I can also retrieve that kind of the data just writing my own application. So here is a Java application. Here is the string URL, and this is exactly what was taken from that example from web portal. And I created the headers. I create a request with the headers, and I got the response. I am using REST template, and after receiving the response, I can do something with that response. Look what is going on. Okay, here I am sending the request using HTTP GET method under the specific URL. But here I also declared a quote class as a class which will be used as a template to which I want to deserialize the response from my service. So let me see. I am sending the request to the cities. So therefore, I create the quote class, and I knew that in my response there will be data fields, links fields, meta fields. So data is a list and links is a list. Can you see? And each list has something inside. Links has 2 fields, right? And the data has 12 items inside. So this is exactly what is here. Quote is a class that has a data array inside, a link array inside. has some set and get methods. And I have a data. Data has all these 12 fields inside. And also it is annotated with JSON ignore properties, ignore unknown to true. So it means that during the conversion between Java class and JSON class, the unknown attributes will be skipped. Okay. So I have a link which has 2 fields. So having that in my client data package, I have a quote class, and after compilation, I am just passing that class to my REST template to the exchange method. And this exchange method will do a very nice thing. It will run the request, it will retrieve JSON, and it will convert that JSON into the Java object, into response entity, and I will be able to get that from that response the Java object exactly as the quote class. So I am printing it on the screen that this is really this quote class, but I can also say response, for example, get body, and body is, can you see, set data, set link, set metadata, and there are also get data, get link. So these are methods of my quote class. So it's really inside the body, and the object that will be given back is of a quote class. So this is the example. To study, to learn this, it's maybe the best way through the examples, because the entry point is very hard. If you want to study all the details of Spring Boot, all the details of this serialization libraries, about the JSON, about loggers, and so on, you will spend a lot of time. So therefore, during the labs, I am asking you just to play with the wizards that offers you for free all these classes, and you just modify parts of the implementations. However, please understand that all these frameworks are designed using some specific patterns, some specific design patterns. Many of them just use annotations. And these annotations, as you may see, comes from different frameworks, from different packages, and they have a different interpretation in a runtime. Okay, so what else? It's already 10:45, so I should finish my lecture, but I have not discussed yet some other patterns which are inside my presentation. So just go through these patterns, please, and look at the content, because during the test at the end of the semester, I can ask about some details of these patterns. So please just study them. So I will mention the factory and the abstract factory pattern. Look, in the factory method pattern, I am using interface. So the idea of using factory pattern is when the client does not know what concrete classes will be required to create at the runtime, the interface it will use. So this is the idea, and the idea is realized or done in that way that there is an abstract product interface. This abstract product interface is the data type which is used as the return type of the factory method. Factory method just returns an object that implements abstract product. However, the implementation of this abstract product can be attached in any time implementation by some classes. But in that case, concrete product class is just an implementation of the abstract product. So to play with this method, there is an abstract creator. Abstract creator is an abstract class which has a abstract method, factory method, which delivers abstract product. And this concrete creator just is an implementation of that it just delivers implementation of that factory method. So you see one interface which is implemented by the concrete class. There is an abstract class, and we have the class which derives from that abstract class, which is the concrete class. And inside that concrete class, I have an implementation of the factory method. And this factory method gives me back an abstract product, which is an interface. And in fact, it can be implemented by various classes. So I have two places, well, maybe not. This place, when I substitute that concrete product class with the other class, is a, how to say, the flexibility of this implementation. Changing that class inside my source code, in one line, I will change the behavior of my application. So how the abstract product is implemented is just an interface. How the concrete product is declared, it implements abstract product and implements this feature method. And how abstract creator is implemented, it has an abstract factory method and an operation. Inside that operation, it just creates abstract product and call the method of that product. This is also very important. Please focus at the moment on that class. See, here is the abstract class. And this abstract class has an operation method that calls the factory method. Look, if I look only without seeing any other classes, just on that class, I can see that here I am calling, here I am calling a method which is not implemented, right? Can you see, right? Here is the abstract creator class, which has an abstract method, which has no implementation, and it has an operation method. And inside that operation, I am calling that method that has no implementation yet. Right? This is just what makes this pattern very interesting. The method that will be called here when the end operation will be called by the client will match the instance method that will deliver that factory method. So this is done here. This factory method is implemented in the class that extends abstract creator. Here is that implementation, and factory method just returns instance of the create product, where the create product implements the interface which was declared above. So this is just what is going on. Such a mixture, right? Here I am declaring a reference to the abstract creator, but here I am saying that this creator will be that one. Here is the line in which I assign the class, in which I create the instance of a particular class. And then I am calling an operation. So when you are using design patterns such like that, so it happens that after changing your source code, after modifying or attaching a new classes, here is only one place in your source code if you would implement another creator, so just inserting this another creator in that place will change the behavior of the whole application. Why only in that line? Because later I am using the, how to say, the reference to the base class, and I am calling the operation, which in fact will be a virtual operation, a virtual method called on the instance that was created in that assignment. Right? So this is what I wanted to say, that playing with the design patterns is, especially in an object-oriented language, relies on using the inheritance, interfaces, encapsulation, all these terms that were mentioned just when I started my lecture, when I started talking about the design patterns, right? So at first it looks, how to say, not very friendly, right? Sometimes it's difficult to analyze how to use that pattern. However, after becoming familiar with the particle pattern, the overhead done to declare all these interfaces and classes will be given back, because changes afterwards are easy to insert in your code. So abstract factory pattern is it has a factory in its name, but it's a bit different. As you may see, this design patterns is a bit more complicated. I have two interfaces which are implemented by two classes. I have no abstract class inside it, right? Inside that pattern, I have only interfaces. So this makes a difference between these two patterns, and you can find that the main difference between abstract factory and factory method is that abstract factory pattern uses a class delegate, but in a factory method there is an inheritance, and it relies on use of subclasses to handle the desired object instantiation. So summarizing, there are some more patterns in the presentation. Just go through them, try to analyze and understand the code which is attached to them. Especially, I like much a prototype pattern, which is, how to say, used when you want to create object of the same kind many times. So, and if you want to decouple the creation, the representation of the objects from the system. So if you want to substitute by this object by different implementations, so the prototype just offers you the method by which you initialize and create a clone of this primary objects, and you can call the operations which are delivered by these objects. So go also through the description of that prototype. You can see that I can create a prototype, I can initialize it, and if I want to have the second object that works in the same way, then I am just running clone prototype, and I am calling the feature of the method of that object. If I want to create another prototype, so I initialize my first prototype with another attributes, and I am cloning that prototype, and I am calling operation on that new object. So this is how it can be used, and sometimes it's very helpful. It allows you to play with once created objects many times, and easy to adjust them to the needs, just because you have the method that change the behavior of the method in it. So this is more or less what I wanted to say. There are some few slides regarding the architecture of the systems and technologies. I will return back to this part during the next lecture. Any questions so far? Are there any questions?
No, sir. Thank you. Thank you.
Yeah. There was a question. I didn't hear you. Okay. Because I didn't hear whether you want to have an access to something or not. Nothing, right?
No, sir. I was I was in my throat, sir.
Okay. All right. So thank you for coming for the lecture. I hope that you enjoy it. The presentations are already on my webpage. However, the example of this item, data types or classes, is not. I will attach it soon to the webpage just to let you know what are these examples and how to play with them. Okay, so I will. It was in here. There was an item, right? I am talking about this project and this example of various design patterns when regarding to the creation of the classes for different purposes. So thank you again, and see you on the next lecture.
Thank you, sir.
Thank you. Have a good day.
Thank you.
Do zobaczenia.